What does bangkit mean to you? Well, for me, this is my experience. Despite coming from a non-IT background, I have always liked to learn more about IT things. I taught myself how to code in Python using various sources such as Udemy, YouTube, and my computer science friends. I even earned some certifications out of them. I got introduced to Bangkit during one of my lazy Instagram scrolling sessions when I saw a friend of mine graduating from Bangkit. I instantly jumped out of my bed and searched for information. Having a background in Python, I got really excited when I saw that the machine learning part was available in Bangkit. I applied for the 2022 intake despite being in my final year of study and having no other obligations in my studies other than finishing my bachelor's thesis. At first, I got sad when I got an email that stated that I was qualified, but I was put into the waiting list due to the amount of applicants. But then, February 14, 2022, Valentine's Day, my first day in Bangkit. I only knew limited things about machine learning, limited abilities on my soft skills, limited abilities on my entrepreneurship skills. Week after week, sessions after sessions, courses after courses. Of course, when I first joined Bangkit, my expectation was for me to be able to do things related to machine learning. The math behind ML, which I got with the Mathematics and Machine Learning course, the syntaxes in TensorFlow, which I got with the Deep Learning.ai TensorFlow developer specialization, and many other courses. But Bangkit exceeded my expectation. I got weekly sessions where I gained some new networks. I got soft skill improvement sessions where I learned so many new things, bettering my daily habit and obtaining new thoughts that I haven't thought of before. I was also pushed to be more creative through Bangkit's challenges where I have to create videos on a certain topic, such as a mock interview situation, explaining habits I've changed, and this one. Okay, so May 16, 2022, approximately 3 months in Bangkit. I am ready to continue learning, I am ready to tackle my obstacles, and I am ready to be who I want to be. So, let's go back to the beginning. What does Bangkit mean to me? Well, for me, Bangkit is where I am always eager to achieve more, eager to push my limits, eager to rise up. Bangkit, it's in the name. How about yours?
Hello everyone. Oh, sorry. Oh, udah. Okay, hello everyone. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Welcome to guest speaker session today. It's so nice to see you all here. Yeah, how are you doing? I hope everyone is in a good health. And I'm Tia. I'm a Bangkit graduate 2020, and I am currently part of learning support team in Bangkit 2022. Yeah, I would like to congratulate you all because you have been doing great in Bangkit. I believe that most of you have been finished all mandatory courses and currently working on a capstone project. I hope your project is in a good progress. And today's very special because we will have a special guest speaker and also a very special topic. As a Bangkit student, we have seen Laurence Moroney through the Coursera course, right? And we also learn machine learning from his Coursera course. But now we can communicate directly with him. I'm very excited, and I believe all of you are also very excited to meet Laurence Moroney, our keynote speaker today. Let me share a little bit about Laurence beforehand. So, Laurence Moroney is a lead artificial intelligence advocate at Google. He is also an author of many programming books. AI and machine learning for coder is one of my favorites. He's also a lecturer in some online courses like Coursera. And in this guest speaker session, Laurence will talk about machine learning update from Google I/O 2022. Okay, please welcome Laurence Moroney to be with us on the stage. Hi, Laurence.
Hi, Tia.
Hi.
How are you? And hi, everybody. I'm really excited to be here too. So this is amazing. I wish I could be with you all in person, but maybe next year. We'll see.
Yeah, hopefully, Laurence. This is the third time you have been in Bangkit event since 2020, right?
Yep.
I still remember last time I'm a student, Bangkit student. I watched you. All right. So yeah, I would like to say thank you for always supporting us. It's an honor to have you here in our session.
Oh, the honor is all mine. Thank you so much. And, congratulations to everybody who's working on this. And that video from Ryan earlier was just amazing.
Yeah, Ryan is one of our best students in machine learning path. All right, Lauren. So the stage is yours, please.
Okay, sounds good. So if we can present my slides. And so I'll just say, well, first of all, everybody, just thank you so much for tuning in. I know it's the morning over there. It's evening over here, 7:30 p.m. So I'm really, really delighted to just spend the evening with you all. I'm going to be talking a little bit about Google I/O 2022, about some of the new things that we've done this year at Google I/O. But also, before I get to that, just to take a little bit of a step backwards, and almost like Ryan was asking earlier on, what is Bangkit? I also want to talk a little bit about why we do what we do and why I think it's important for the world to have an open source ecosystem for AI and machine learning, and what it is that we're doing to drive that forward. So I'm going to start with this really boring slide. And this slide is, I took a look at economic output in several countries, mostly in Western Europe and North America, since the 1940s. And economic output of these countries, I deliberately haven't put axes on these because I just wanted to show that in general, it's a line pointing upwards. And let me just get my animation down. There we go. And it's a line pointing upwards like this. And as a result, we see that economies have generally been growing, except for that cliff over on the right-hand side. And that was, of course, the downturn in various economies because of the COVID pandemic. But in general, when you look at a chart like this, when you just see everything has been growing, but some of the detail about the things that have the bigger impact tends to be missing. So I redrew it like this. And so this diagram I wanted to draw as, instead of looking at the GDP growth in particular countries, I wanted to draw the GDP growth as a function of the previous 4 years, with the idea being that we can then see the places where the countries and the economy of the country grew the most, and then the places where it was growing very poorly. And as a result, we can see there's a couple of peaks here, and there's a couple of areas like this one, where we can see over this period of time that there was very, very strong economic growth in these countries. And this period of time is, and you see, by the way, I put the label on the right side. So when it's 1.0, that means the economic growth in that particular year was roughly the same as the average of the previous 4 years. So when it grows above 1.0, that's when you know you're in really good shape. And this part that I've circled was the years from about 1993 to about 2006. And this, of course, was the advent of the internet and the internet-led economy. Prior to this time, companies like Google didn't exist. There was no need for them. Companies like Apple were very small companies making specialized computers. Microsoft were a relatively small company making operating systems for PCs. And a lot of the big players like Amazon and all of those big online retailers simply didn't exist. But with the advent of the internet and the advent of the ability to build websites that will execute on web servers that could be viewed from almost anywhere, the economy changed and the economy grew greatly. And so, like I said, prior to this, it was a totally different economy. And look at how big the economic impact of that has been. The second one here started in about 2007 and has lasted until roughly about now. And this, of course, was the advent of the mobile economy and the mobile phone. So between the iPhone and Android, those two are the two dominant platforms on the planet. And not just the handsets themselves, but the entire ecosystem that was built around those handsets, the app ecosystem, again, has caused tremendous growth and tremendous job opportunities. And I mean, I cite one statistic that I read was that in the year 2020, the Apple ecosystem in the United Kingdom alone generated 600,000 jobs. And please note that that was in 2020, which is on the right-hand side of this diagram, which is that massive drop because of the COVID pandemic. So despite the pandemic and industry slowing down and grinding almost to a halt, the mobile phone ecosystem was actually growing. And in an economy in a country of like 70 million people with maybe a workforce of 30 to 35 million, the Apple ecosystem alone, in this case, generated 600,000 jobs in that year. So the mobile advent and the mobile economy has also been huge. Now, the next one, of course, we want to talk about is AI and machine learning. And the World Economic Forum consider AI and machine learning to be the fourth industrial revolution. And if we go back to this chart, I anticipate 10 years from now, if we're doing a bangkit like this, there will be another peak there, which was the AI economy, which will be much bigger than this one and certainly bigger than this one. And that's the opportunity that's in front of us right now. And that's the opportunity that's in front of all of you right now, in studying in bangkit, understanding machine learning, understanding AI, and being able to build for that. And it's not just me saying this. So the World Economic Forum, like I mentioned, they call it the fourth industrial revolution. But in 2020, they put out a report on the jobs of tomorrow. And they saw this growth in future jobs, data and AI growing 37% by 2025. And that's only 2.5 years away now. Engineering and cloud computing growing 34%. And everything around that also growing very, very sharply. So they really saw the number one driver of economic growth and the number one driver of people of skill being able to build strong careers is data and AI. So by being part of bangkit, by learning this stuff, you're helping yourself, you're helping your country, and you can really, really help build your economy and build your own personal future. So I know it's been a lot of hard work, but I just want to say, hopefully it's been fun, but as well as fun, you're laying that foundation for your future and for your country's future. So congratulations on doing this. Indeed, Forbes made a similar report, and they were looking at the global ML market. And if you take a look at it, in 2017, the ML market was about 1.5 billion US dollars. By 2024, they expect it to be 21 billion US dollars. A massive growth in just 7 years. And that's a compound annual growth rate of about 44%. And then software revenue in AI in 2018, 10.1 billion. By 2025, they expect it to be 126 billion. So the amount of economic growth that's coming out of AI and ML is absolutely staggering. And again, by studying this, by getting certified in this, by building a career in this, you can be a part of that, and you can help your country to be a part of that too, which I just find really amazing. So what are we doing? What are we doing to help that? So the vision that I have for my team and for Google that we're driving forward is to really think about what it is for you to really build in AI. And, what is the general workflow for anybody to be successful? And it kind of, the workflow generally falls into these 4 columns. The first column is understanding data. And if we can build a free and open source ecosystem for data so that you can bring your own data or you can use hosted data, and you can do it in a way that's easy and it doesn't involve a lot of investment of time and effort on your side to be able to get that into machine learning, that's a big win. And as I'm going to show a little bit later on, when it comes to the amount of code that you write, this is probably the part where you write the most code. So anything that we can do, again, free and open source, anything that we can do to help that, to shorten the burden of code writing that you would have, means that you will be accelerating to the next step far more quickly than if you have a lot of work to do on the data side. And then the second column, as you can see here, is model architecture, definition, and training. And here's where you really get into machine learning. And most of machine learning and most of the code, again, that you'll write in this is defining your architecture, defining your hyperparameters, choosing how you train it, choosing like your splits of your data and that kind of thing for training it, and tweaking your architecture to make sure that it works, as well as being able to monitor it as it goes along. So a lot of the interests in AI and machine learning and a lot of the lessons that people teach are on this column. But this is only one part of a much bigger ecosystem. And it's we really want to make sure that, again, free and open source is available. TensorFlow as a framework, JAX as a framework, the modeling architectures on top of JAX are all available to developers without any kind of vendor lock-in and without any kind of outlay of expense up front. And then we try to back that up with the best training that we can do with things like the Coursera courses, the YouTube channel, tensorflow.org, and that kind of thing. So, you know, the expertise needs to be learned for the model architecture, definition, and training, but that's only one small part of the bigger picture. And the next part, and perhaps the most important when it comes to generating revenue, is where you deploy a model. It's all very well to know how to build a model, and it's all very well to learn the training of like building an image classifier or something for natural language processing. But if you can't get it into people's hands, it can't do any good. And of course, if you can't get it into people's hands, then you're not going to be able to generate any revenue from that. And in the ecosystem, we've been looking at, well, where can models be deployed? And there's really 6 main families of that. Number 1 is the scalable cloud. Number 2 is a traditional web server. Number 3 is the browser, so to be able to execute within a browser. Number 4, of course, is native mobile on Android and iOS. Number 5 is embedded systems, so to be able to build and run on something like a Raspberry Pi or an Arduino. And then finally, of course, is microcontrollers. And you know, the last 2 of these are the ones that are going to be driving massive growth as we go forward, because the amount of microcontrollers coming online every day greatly dwarfs the amount of computers, the amount of browsers, and the amount of mobile devices. So as you see moving into the future, being able to build artificially intelligent applications that run on embedded systems and microcontrollers is going to be extremely important. But your job's not done once you've built a model and deployed it, because you know, as soon as a model is deployed and as soon as it's being used, there's the opportunities there for you to grow that model and do better with it and continually update that model. And that's the 4th column here, monitoring and maintenance. So to be able to do what's commonly called ML ops, and so that you can have that virtuous cycle of being able to, you know, continually update your model, continually understand how it's being used, continually deploy it and improve it. So those are the 4 columns and the 4 phases of when you're building software and you want to build out using AI and ML. But spanning all of these are 2 others. And number 1 is accelerated infrastructure, the blue rectangle here. You can build machine learning wherever you like. You can do it on the CPU of your computer. You can have a GPU, or you might be able to afford to be able to use TPUs. But the idea is that we want, again, as part of this free and open source ecosystem, to make sure that you have access to the best accelerated infrastructure possible, so that if it's important for you to accelerate the data ingestion and pre-processing, to accelerate the model architecture, definition, and training in particular, then you have the hardware available to you to do so. And that hardware is compatible and fully compatible with the stuff, with the software that is free and open source. And then finally, and importantly, the green rectangle across the top here is to be responsible. You know, AI and machine learning can lead to very, very powerful solutions. And with great power comes great responsibility. So we want to make sure that tooling is available across the board to allow you to be responsible. And there's a lot of people who talk about responsible AI and who talk about how important it is, but we're the ones who are building the tools that will allow you to do that end to end. You know, often the tools tend to focus on the data. And if you're only looking at the data to be responsible, it's a good start, but it's not enough. We also want to help you to make sure that your models and your solutions are responsible end to end. And that's why I've drawn the green rectangle this way, spanning all of them. So this is the ecosystem as it stands. This is the ecosystem as we're growing it. This is how we announced and declared it at Google I/O. And now I'm going to go into some detail on each of these. So first of all, let's look at data ingestion and pre-processing. So what we've been doing around data ingestion and pre-processing, again, is building APIs and releasing APIs that will allow you to acquire data. So whatever format your data is in, to be able to acquire that and make it easy for machine learning models to use it. To pre-process the data, because you don't just generally pick up your data and throw it at a model. There's a lot of pre-processing that you might want to do. And then, of course, is to use your existing data, bring your own data to that if you want to do so. So with this in mind, especially if you want to get started, what we've been doing is taking a lot of our data sets that we've created, as well as data sets that the community have created, and to make them easy and ready to use in just a few lines of code using TensorFlow data sets. The goal here is to spur your ability to learn how to do this by giving lots of different data in lots of different scenarios, from images to audio to natural language processing and a whole lot more. Small data sets, if you want to just get started with learning, all the way up to massive data sets that we've actually used in research ourselves, like the many, many tens of gigabytes of data that are in the diabetic retinopathy database, for example. We're providing all of them in a way that's relatively easy for you to use. You just write a few lines of code and the data set is ready for you to go to train with. So we're continuing to innovate and continuing to build on TensorFlow data sets. And just to give an example, here's like, this one is the cassava data set. So if you're familiar with the cassava data set, the idea behind this one is, this is for use in spotting crop diseases and to spot crop disease blight in cassava specifically. And, we worked on gathering a lot of data of cassava plants, both diseased and not diseased. And when you gather data like this, if you want to do your own, it's not that simple, because you've got lots of different images. They got lots of different dimensions. They're taken with different cameras. So there's different brightness levels and all of that kind of thing. And if you want to use a data set that has been built in that way, you can do it with just a few lines of code like this with cassava, right? So the idea is like you just say tfds.load cassava, and you define your data set, and now you have a single line of code, the ds.shuffle, that will shuffle that data set, and then you can start taking samples from that and training your model straight away. Now, often, before I go on to that, and as a result, as I've mentioned, there's lots and lots of data sets in there. Have a look at them, play with them, understand them. And before you start getting into building up your own data sets, you can actually learn a lot from the data sets that are in here. And then, of course, there's Kaggle. And Kaggle, of course, is one of my favorite destinations if I want to find new data sets, and as well as people from the community who've built notebooks for those data sets. And there are tens of thousands of those. So it's a great place for you to be able to start. And of course, Kaggle is now part of our ecosystem, and we're continuing to invest in that. Crowdsource is an app that we share, and you can get started at crowdsource.google.com. And this is one that we've done to allow the community to gather data in a number of scenarios. For example, speech donation is a really cool one, so that we can understand different accents, we can understand different languages, we can create data sets from those that people gather, we can curate those data sets, and then we share them back with you so you can start building with them. And when it comes to using data, the whole idea, I'm a coder, I tend to think in code, and you'll see a lot of the stuff that I talk about is in code. So for example, here's like a model, I can't remember, I think this one's a cats versus dogs model. And you'll generally see a lot of code like this. This is the amount of code that you typically write to define your model. And this is the one that you spend the most hours studying. I'm sure most of you in Bangkit have been studying how to do modeling, how to do hyperparameters, how to understand convolutions and embeddings and vectors and all of that good stuff. But in a piece of code like the one I'm showing, this is the amount of code that you do for the model. This is the amount of code that you do for the data, right? So the investment that you have to make in building your ML model to be used by people, a significant amount of that is in the data. And this is the short version, right, with the APIs and the tools that I've been talking about. Prior to this, the amount of code that you would have here might be 10 times this much. So now once you have data, as you're trying to define your model, there's lots of ways that you need to pre-process the data. For example, you might want to slice the data in different ways for experimenting and removing bias and adjacency biases in your data and that kind of thing. And the idea of slicing is something we've designed to make very, very simple. And here you can see some simple code that just shows how to slice the data differently, so you can experiment with different slices in your data when you're training your model. If you want to split the data set, you'll often want to split it into 3 parts: one for training, one for validation, and one for testing. And sorry, it's just started raining here. It's very loud. I don't know if you're picking up the rain. I'm just going to close my windows. I'll be right back so that they're not loud. One moment. Sorry about that. I live in Seattle where it rains a lot, and it just got very noisy rain. So anyway, so then if you want to, for example, train a data set, one of the things you're going to do is split it into typically training, testing, and validation. But why trust the training, testing, and validation set that the data set author gave you? If you really, really want to make sure that your model works right, you're probably going to have to experiment with lots of different splits. And as a result, we want to make sure that you have the ability to make those splits the way that you want, in a way that's simple to code so that you don't introduce a lot of bugs. So again, TFDS is giving that to you, splits. You want to shuffle it. Is a very simple one. Is again, data sets may have adjacency biases where you have data that you collect, but data that you collect at the same time might be very similar to data that you collect, very different, very similar to data collected at the same time, but different to data collected later. So for example, if you're taking photographs of cassava, today it might be sunny when you go out and take those photographs. Tomorrow it might be cloudy when you go out to take those photographs. And if those photographs are in sequence in your data set, and then you end up splitting it so that the training data has sunny and the testing data has cloudy, they're going to be very different. So you want the ability to be able to shuffle your data. So again, when your data is in TFDS and it's in the TF record format, the APIs are there to make that simple for you, so you don't have to write hundreds of lines of code to be able to shuffle it. Stuff like that is very, very important to be able to make your work a lot easier. And then, of course, there's sharding data. So the idea, this one's a little bit more complex. But for example, if you are training across a number of GPUs or TPUs, and you want to split your data, not just into training, testing, and validation, but your training data, you want to split that into, for example, 8 different sets of data that you're going to train on 8 different cores. That's called sharding. And we want to make sure that that's very, very easy for you to do as well. For example, even if you use Google Colab and you use the TPU in Google Colab, the free TPU in Google Colab has 8 cores. There's no point in passing the same data to each of those 8. It's not very, it's not very efficient. But if you can shard your data to each of these individual 8 and send it that way, and you have an easy API for you to do that, that's the goal behind this. So, yeah, and again, finally, like you can put it all together by shuffling, batching it, mapping it, and doing data augmentation. So we do want to make it simple again to do augmentation. If you're not familiar with augmentation, the idea here with augmentation is that it can allow you to turn small data sets into much larger data sets. So for example, if you're doing a computer vision, I'll go back to cassava. So the cassava plant might be oriented like this with the leaves pointing downwards. But if you train a data set and the leaves always look like that, the computer vision model will only be able to recognize leaves that look like this. So what if there's a photo of a diseased plant which is oriented this way? It actually won't recognize that as diseased. So what do? Do you have to take lots of photos of the plant in all orientations? Well, the answer is no, you don't. And that's one of the ideas with data augmentation, is you can take relatively few images and maybe all of your images look like this, but you can actually augment it to create copies of the images that look like this and this and this, so that you can train with those orientations. And that's the idea behind data augmentation. And the nice thing you can do is you can slide your images into your model as you're training. You can augment them on the fly. So as a result, you can have much better coverage of potential images to be able to spot the correct features as part of your training. And again, we want to make that simple. Those are some of the APIs that we'll be pushing. At Google I/O, in particular, in Keras, we announced and released pre-processing layers for computer vision augmentation and for natural language processing augmentation. So there's some good stuff going on in that space. And it's something that I definitely recommend you look into, because this is the kind of thing that can save you hundreds of lines of code while you're building better models. All righty. So as part of the responsible effort, Know Your Data is a tool that we brought out. And what it does is it passes your data to a number of existing models. and it helps understand how that data is parsed by those models. Now, let me give you an example of this. And this one's really cool. So if you did my Coursera courses, you may remember there was a data set called Horses or Humans. Now, the intent I had with that data set were really two things. Number one was to have a brand new data set that nobody's ever used before, so that we could really learn anew how to do things. And given that I didn't have the money to hire a photographer and to hire a lot of models, both horses and humans of all different shapes and sizes and colors and genders, I had the idea of, well, what if I do this using computer-generated imagery? And with computer-generated imagery, I can now easily and cheaply have photoreal models who are Asian, who are Black, who are white, who are Southern Asian, who are male, who are female, in different poses, in different locations, with different lighting, and all of these kind of things. And as a result, I can have an unbiased data set. That was my intention. And so I deliberately went out to have an unbiased data set in that way. And similarly with horses, you know, all different colors, all different shapes, all different orientations. But people tend not to be worried about bias in horses, but we are worried about bias in humans. And so my intent was to have an unbiased data set. I then passed it to the Know Your Data tool, and try it yourself in the Know Your Data tool. And it ended up, one of the things that the Know Your Data tool is, it passes all of the images to a cloud model that tries to determine if there is a face present in the image. And what ended up happening is that a lot of the images that I used in Horses or Humans that had darker skinned people, many of them, the face wasn't recognizable. You know, the way that it was lit, the way that it was posed, all of those kind of things. Despite my intention of creating a data set that was unbiased, I actually still created a data set that was biased. So even when somebody is intentionally creating an unbiased data set, you can create a biased one. So what happens if you weren't even thinking about that to begin with? How easy it is to become biased in your data sets. And as a result, Know Your Data is really, really powerful and really, really useful. And I thoroughly recommend you have a play with it, you experiment with it, you understand how it works to remove any of those kind of biases at your data. It's not just data, there's also text. So we released something called the Language Interpretability Toolkit. And what the Language Interpretability Toolkit, and this came out at I/O, does is a very similar thing for language. And what it will do is it'll help you spot instances of language that you're using where bias might be involved. And for example, in this case, it's skateboarding. And, you know, it was very clear in the data set that we're using here that skateboarding was almost exclusively associated with males. And that's not fair. There's lots of great female skateboarders out there. And skateboarding is an open hobby for anybody. But in this case, in this data set, skateboarding was very clearly associated. You can see here, male, man, boy. Right. And being able to spot things like that in your data set and have a tool to help you do that, vitally important. Okay, and yeah, this is just another example of, you know, Language Interpretability Toolkit, how you can dig into your data and understand it. Okay, so that's some of the things that we've been shipping around data. We've been updating, working hard on TFDS. We've been working hard with Kaggle to have lots of new data sets and notebooks. But in particular, the APIs for pre-processing to give you data augmentation, you know, are things that you really, I think you should look into because they can save you a lot of time and effort. So now when it comes to training, so the common thing I always like to show is something like this. And machine learning, when most people learn it in academia, they learn it as a discipline, as a computer science discipline, which generally involves a lot of math. Now, there's nothing wrong with that. You're learning the theory, you're learning the underlying basics, but it's hard to implement. And for a lot of people, it's hard to learn. So our focus has always been on code and being able to ship code that implements that math so that any developer can start building machine learning systems without needing to learn calculus first, without needing to learn any of the underlying mathematics first. So in the model architecture, definition, and training, you know, there's two main families of things that we're doing. Number one is to ship a bunch of APIs that make it easy for anybody at any skill level to be able to ship machine learning models, as well as a lot of pre-trained models that you can build on instead of starting from scratch. In the API space, one of my favorites is Keras. And the nice thing about Keras is that it's taken the complexity of neural networks and made it simple to code. You know, we've probably all seen something like this, a neural network like this. And in Keras, all you're doing is saying, here's the layers. The first layer has 3 neurons. The second layer has 2 neurons. I can define the activation function based on name. I haven't written a single piece of math or anything like this. And a really powerful neural network like this one in just a few lines of code is really powerful. But it's not just a toy. With Keras, you can also define very complex networks. So for example, this network here is a UNet, and it's used for image segmentation. And this can be defined relatively easily in Keras as well. And you can see some of the output image that was defined from one like this one, where there's a pretty complex image here of 2 ladies in Japan wearing kimonos against a background which is very similar colored to what they're wearing. But the segmentation model is able to determine that and is able to separate them from the image. And this doesn't require intense math, intense computing. It can actually be defined using Keras, using a high-level API. It's pretty cool. Or this one, which is called Path Dreamer. And the idea behind Path Dreamer was Google Research trained a model on a number of houses and on the interior of houses, with the vision behind this being that if I can take a photograph of a particular location in a house, can I predict what the rest of the house would look like? So in this case, we took a photograph of the lobby in this apartment and built a model that could predict what the rest of the apartment looks like. So it is actually looking around corners to predict what the other rooms would appear to be, you know, including depth maps and all of those kind of things. And this was built in Keras. And another one which I find really amazing was this was built by the community, and it was a researcher who wanted to build a model that could be used in retirement homes. And one of the biggest problems with people in retirement homes is that they can fall and they can be very badly hurt if they fall. But for privacy reasons, you can't put cameras in a retirement home. It'd be easy if you had a camera and you could build a model to determine if somebody fell and you could spot that and raise an alarm. But the privacy violation of having a camera online all of the time is horrible. And you know, it's just not fair to the residents if you were to do that. So this person did it with radar, where they have radar that can see through walls and can even see, in this case, person B is hidden behind person A, with the radar being on the left. But they were able to build a radar model with depth estimation in Keras that could determine if person B fell over, and no camera in the room, no privacy violations, and all done via radar. So imagine the implications of being able to do something like that, where we can have much better health monitoring in retirement homes, or even for our elderly relatives who live at home with us, without the necessity of having a camera in the house. I find it's amazing. This is research that just came out. One of the things that we've been investing heavily in, and we released a lot of new stuff at Google I/O, is TensorFlow Lite Model Maker. And one of the pieces of feedback that we get is that for people who want to get started with machine learning, you know, and who are Android or iOS developers, don't want to learn Python, don't want to learn neural networks, don't want to learn machine learning, you know, but they still want to build models. So it's our goal to make it as easy as possible for them to do so, and to abstract away a lot of the difficulties into some code that they can then use. And particularly based on, I mentioned earlier that we've pre-existing models. So in their scenario, they can build using those pre-existing models, transfer, learn with those pre-existing models to build something new, and then have all of the stuff to be able to convert that to be able to run on mobile done under the hood for them. So as a result, if you think about it, when you're generally building a machine learning model, like here's an example of if you want to do text classification, you know, you got to have a data loader for the text. You got to do the data stuff for splitting the text. You got to define the features in the text that you want to do. You got to define your labels. With text, you then generally have to tokenize it. You have to build sequences. Then you define your model. Then you train your model. Then you evaluate your model to make sure that it works. And then you learn how to convert that model into a format that will work on mobile. It's a lot of steps and it's a lot of code. TensorFlow Model Maker turns it into this. So for example, this is a mobile BERT classifier. And in 3 lines of code, You know, you have your data in a CSV file. You don't need to worry about anything beyond that. You just say text classifier data loader from CSV, tell it the columns that you're going to use, and off you go. You have being able to split the data into training and test data. Here we just say data.split 0.9, 90% of it for training, 10% of it for testing. And now here, if you want a text classifier.create with the training data, and off you go. It's really that simple with Model Maker for you to be able to use even pretty sophisticated models like BERT. And one of the things that we showed at I/O was research done by a student in Germany. And this person wanted to stop the problem of child sex predators, where the predators meet the children in chat rooms and in online chats, by building a model that could use text sentiment to start spotting the patterns of when somebody is grooming. And a very successful model that they've built. They built a research implementation. They've shared it open source, even with an Android application. And they built this using Model Maker. And this person was not a machine learning engineer. This person was somebody who wanted to build something like this that could be helpful to the world at large. And the feasibility of building something like that prior to machine learning, you would need millions of lines of code and a lot of specialist knowledge. Now with the machine learning revolution and with what we're trying to do with TensorFlow to empower people with that, here's a great example of something that somebody did. And this is from his code. And here's 3 lines of data to be able to build that classifier. The next problem that you'll face when you want to deploy a model to mobile is compatibility. The clue is in the name, TensorFlow, right? Tensors flow through your model. Your input data is tensors, your output data is tensors. But when you are building an app on, for example, Android, for example, if you wanted to do an image classifier app for Cassava or something like that, you're going to be passing in a bitmap and you want the user to be able to see a string. You know, so how do you go from bitmaps to tensors? And then how do you go from tensors to strings? There's a lot of coding necessary there. There's a lot of understanding of how things are formatted necessary there. And as a result, that's a lot of extra overhead that you need to understand and learn. And we said, well, as part of Model Maker and with the stuff that we're shipping at Google I/O, let's ship a lot of APIs that make this easy for developers. So they're called the helper libraries for TensorFlow Lite Model Maker, and there's task library as well. And the idea behind these ones is that they handle that complexity for you. So if you're an Android developer and you don't want to deal with the complexity of machine learning, or if you're a machine learning engineer and you want to work with Android developers, then the idea is to have best practices for that encapsulated into libraries that are open sourced so you can learn from and extend them, and to make life much easier for mobile developers. And at I/O, I'm only showing Android here, but at I/O, we actually shipped the helper libraries and task libraries for iOS as well, so that as a mobile developer, you're wide open to the stuff that TensorFlow Lite Model Maker can give you. So again, we really want to seed the ecosystem, as it were. TensorFlow Lite Model Maker at I/O, we also shifted a lot of new model types, shipped a lot of new model types, including this really exciting one is the similarity search. So for example, if you wanted to build a model where you want to build an app where, for example, if somebody takes a picture of a birthday cake and you want to find the images that you have that are similar to that, now instead of you needing to create custom models and convert them for mobile and all that kind of thing, they've been shipped as part of Model Maker. And so we're continuing to add new model types to this all the time to make life much easier for mobile developers, but by extension also for web developers, because even though I'm not showing it here, one of the things that we've done is to allow the TensorFlow Lite model format to work with TensorFlow JS. So instead of you needing to do a further conversion of your model to be able to run it in the browser, if you build it for iOS or Android using Model Maker, then the same model format can also be used in the browser. So if you wanted to build a browser-based app, there's lots of scenarios for where you would want to do that, one of which is mobile phones that are not Android or iOS, but are feature phones that only have a browser. Then you can now start bringing models to them too. And as an example, I mentioned iOS. Here would be an example of like iOS when you're using the helper libraries in iOS to do object detection. It's really as simple as this, right? You define an options, you define your object detector, and then you have like your detection result is object detector dot detect, and then you just pass it an image in your native format, and it will do all of the heavy lifting for you. Of course, there's Google Colab. We're continuing to build and invest and innovate in Colab. One of the things that you will see is the latest versions of TensorFlow are always shipping in that, and we're always supporting more and more backend libraries in that. And the one thing that I always recommend that you look at, that we continue to innovate in, and we've been pushing at I/O, is the hardware backend for that, because it gives you free GPUs in the cloud for accelerated training and free TPUs in the cloud. And I think the TPU is very important, because if you want to get into a career, particularly in large model development, the TPU is essential. Now, not everybody has access to TPUs today. They can be expensive because they're so powerful. But if you want to get started with TPUs, you can actually do it in the cloud with Colab. And the skills for being able to build with them start with something called distribution strategy. And distribution strategy, the idea is like, here's a piece of code that helps you to define a simple model, compile and test it using Keras. But if you want to do that on a TPU instead of on your CPU or GPU, this is all you have to do. You define a strategy, and you have a TPU strategy in this case, and you put your model definition and everything else within a strategy, and now you can start training on a TPU. It can get a little bit more complicated than that if you want to optimize. For example, as I was saying earlier on, if you use the TPUs within Colab, that actually gives you a free TPU that has 8 cores. The very goal of that is so that people like yourselves can build the skills in understanding how to shard your data across 8 cores, understanding how to split your model across 8 cores to make it very efficient, so that if you do end up going into a career building large language models, you're not starting at zero and joining the company in the hope that you can do it. You can actually build the skills and show the skills today, so those companies who are defining large language models who are doing this can see that you have those skills. It's really, really important. And like one example of a company that we worked with at I/O is Cohere. And Cohere build large language models for text generation, classification, sentiment detection, all of these kind of things. And when they moved to TPUs and they moved to sharding their models and data on TPUs, they increased their training time by 7. So they got 7 times faster, which means they can bring a product to market quicker, or they can be able to evaluate and test and purify and update their model 7 times quicker so that they can build better models. And they did that using TPUs. And so again, it's out there, it's available for you in Colab to start using TPUs. Strongly recommend it, so you can build the skill set and you can build your portfolio. And all you have to do is share the notebooks that you've done this with on GitHub or elsewhere, so that potential employers in this space will be able to see that you already have those skills. So going back to the ecosystem, that's really like the 4 things that I mentioned. We've finished with model architecture, definition, and training. Next up is deployment. So deployment, of course, I think is probably the most important. And if you're building anything, and if you're building anything commercially, you might want to start with here to kind of figure out, well, where is it that you want to deploy? And then, if you're maybe only building for microcontrollers, that will dictate how you do your model architecture. That will dictate how you do your data. So there's different attributes and different necessities in all of these. But model deployment, first of all, cloud. So being able to deploy to the scalable cloud, to be able to deploy into virtual machines or into serverless environments with things like cloud functions, you can now do that. Because of TensorFlow.js and cloud functions that run node backends, you can now deploy machine learning models into serverless environments. And so, many, many applications will be built on this. If you're not familiar with the idea of serverless, the goal of a serverless environment is you can build functionality that runs in response to some kind of a trigger. So for example, somebody logs into a system, that's a trigger. You want to spin up a virtual machine that runs some code, in response to that login, maybe to check for security, maybe to check for hackers or something like that. Instead of you having a server on demand that you're always calling. That's the idea behind serverless. Spin it up when you need it, spin it back down when you don't need it anymore, and only pay for the capacity that you use. Things like that, you know, very cloud specific, and we want to make sure that ML models will operate in them. Then, of course, there's the traditional web server, right? So HTTP 80, HTTP 443, gRPC, stuff like that, to be able to run a model on them and to be able to serve that model to users and to do the inference on the server so that the data gets passed to the server, the inference takes place there, the results get passed back to your clients. Again, very important. The browser, as I mentioned earlier on, that often, you know, it's the easiest to install applications on the browser because they just happen automatically. You browse to them, hence the name, to be able to run maybe on devices that don't have a runtime like Android or iOS, where feature phones have a browser, you know, and just to have the easy reach of the browser is a very valid surface for you to put your applications on. And of course, we want to make sure that they run there. That's what TensorFlow JS is all about. And the big extension that we've been talking about recently, of course, is the fact that you can now run models from the TensorFlow Lite format in the browser using JS. So you don't need that further conversion. Mobile, I've already spoken about a lot, but the idea is to have native acceleration of mobile apps, mobile models on both Android and iOS. And if you're an Android developer, one of the really nice things that we've shipped at Google I/O was the ability, was that the TensorFlow Lite runtime is now part of Google Play services. What that means is that you don't have to bundle the TensorFlow Lite runtime with your app, which makes your app much smaller, first of all. And then second of all is that the device will automatically be updated with the latest version of the runtime. So you'll always get the fastest, the least buggy one out there. Now, this is a big deal because, you know, for the last few years, as people have been building apps that run on mobile devices, one of the biggest things that we see in support is, my inference is really slow. What is wrong? And the first question that we ask them is, what version of TensorFlow Lite are you using? And they go and they take a look and it's version 0.0.1. You know, they're using like really pre-release versions. They bundle that with their app, they ship their app and they never updated it. You know, and then they have to go through the process of recompiling their app using the new versions and, you know, shipping those. And that's a lot of work. And the nice thing, what we've announced at I/O for Android developers is it's part of Google Play services. So now your phone will always be updated with the latest model, with the latest model runtime. You don't need to ship the runtime. You can just ship your model. Embedded systems, of course, things like Raspberry Pi and Arduino, to be able to build things like the radar that I spoke about in the retirement home. You would build it and run it on one of those. You're not going to be putting cell phones or web browsers or cloud in retirement homes, but you can put a Raspberry Pi with a radar detector on it, and you can run models on those. So being able to do those kind of things with very, very cheap, very small computers, you know, opens up whole new scenarios where you can build applications that nobody was ever able to build before. And then when you get even smaller with microcontrollers, you know, so that, you know, maybe it's a thermostat or maybe it's a simple device that you want to have intelligence on instead of typical rules. Again, the idea is that you can build models and you can deploy them and run them on these. This is a little bit more bleeding edge than the other ones. You might have to dig down into C++ to be able to do it, but we're continuing to advance, you know, in that space. And then finally, and then of course, like you can have bugs in any of these kind of things. You know, you're going to deploy something, it's not going to work perfectly first time. So as a result, we want to make sure that you've got good monitoring and maintenance of your deployment. You can understand how your model is being used in the wild. You can gather data about that, and you can feed that back as new data that you're going to ingest to maybe redefine your architecture or retrain your model and then redeploy that and set up that continuous life cycle of having better models running. To that end, TFX is, again, fully open sourced, and it's an ML ops platform. And like this is, we call this the hello world diagram of TFX. TFX stands for TensorFlow Extended. And when you want to start getting down into the nitty gritty of that life cycle that I spoke about, of having that constant workflow so that you can continually ship new models. And let me give one example of this is, say you're building an online store. And that online store will give recommendations similar to the thing that you're looking at. And those recommendations are based on what other people have bought. So for example, if you're currently looking at a pair of shoes, the people who looked at this pair of shoes also bought socks, and these were the most popular socks. Now, as you can see, that scenario can change not on a daily basis, but that can change on an hourly or a minutely basis. And in order for you to drive your business forward, you need to make sure that that model is constantly updated based on user behavior. And as a result, you're not going to build a model once and ship it and then sit back and forget about it. You're going to have that continuous cycle going on. And the idea is to have the tools that make that easy for you. And that's what the idea behind TensorFlow Extended. And we announced at I/O that TensorFlow Extended has now reached 10 million downloads. It's being used all over the world. I'm sure there are products that you use every day that use TensorFlow Extended. If you listen to music with Spotify, they're one of our biggest clients. If you use Twitter, they're using TensorFlow Extended, as well as a whole bunch of stuff from Google. And going back to the responsible AI part of it, one of the easiest and most useful things you can do when you deploy a model is to have a structured way of letting people know details about that model so that they don't unintentionally cause problems using that model. And the Model Cards framework and the Model Cards toolkit from Google Research was designed with that in mind. So with TFX, we built an extension to make it really easy for you to create a model card. And as a result, if you want to be able to publish your models that other people can consume and not make mistakes with and not have bias issues with, you can open up the way of describing that model using these model cards. And we've made it easy for you to do using TFX. And okay, so one of the things that we did at I/O is that we heard a lot from developers that they really love the idea of having models running on a server infrastructure, having the inference done on the server, particularly where it's like you want to update the model continuously without distributing it to new apps. You want to use the power of maybe GPUs or TPUs for advanced inference on the server. So TensorFlow Serving, which is part of TFX, was designed with that in mind, but it's pretty complex to use. If you're a Python backend developer, you know how to do it. If you're a front-end developer who loves Flutter or JavaScript or Kotlin or Swift on iOS, it's not the world that you live in. So what we wanted to do was put together a set of learning paths, so you can see them at this URL, that take you through the full scenario of building a model, deploying it to the server infrastructure, wrapping it in TensorFlow Serving, accepting data from a Flutter web, native Android or native iOS app, reformatting that data into tensors, passing those to the model, getting the output from the model, sending that back down the wire, and then getting the apps or website to actually update in response to that. So we've done at I/O, we did these end-to-end learning paths for that so that you can go through these and you can see how they all work together. It's pretty cool. Earlier, I mentioned TensorFlow Lite and Google Play services. This is something new that we shipped. And again, minimizing your APK size, regular performance improvements because of these automatic updates. And we use it ourselves. And we have, as of now, 400 million monthly active users of this. And there's about 20 billion daily inferences on MLKit, which has been shipped in this way. So we know that it works at scale. And if it's working for us in that way, we know it can work for you. So if you want to distribute Android apps, strongly recommend looking at this. One thing that we also shipped for I/O, but a little bit before I/O, was we wanted to widen access to AI and machine learning. So partnering with edX, who we also partner with Harvard and edX on our TinyML courses. But we wanted to launch this new one, which is really AI for anyone. And the idea behind AI for anyone is that it's 2 courses. The first course is I Teach, and it's all about, this is what AI is, this is what ML is, this is how it works. Let's demystify this kind of thing so that you don't have to be an engineer. It'll help like maybe the business people in your company, the people who aren't going to be engineers building this kind of thing, to understand what it's all about, to bust through the hype cycle and to be able to understand what it's really all about. And then the second course is the world's most popular programming language is JavaScript. So in the second course, we use JavaScript to teach how to build machine learning models. It's actually pretty cool. Strongly recommend taking a look at it. And as its name suggests, it's really for anyone. In Korea, we piloted an ML bootcamp where the idea is kind of similar to Bangkit. The idea was we created a cohort with the idea of this cohort being to learn how to do machine learning aimed at taking the TensorFlow certificate exam, but we also do job coaching. So partnered with local startups and local companies to be able to place the graduates of this into local companies, either as interns or full-time employees. And this is now being expanded actually to 6 places. I'm showing 5 here. It's being expanded to India, Latam, Africa, Turkey, Japan, as well as Central Europe. There's a new one just launched in Central Europe. So the idea of these boot camps are things that, you know, we really believe in and we're extending. Very similar to Bangkit, but a lot smaller than Bangkit. So congratulations with what you're doing there. The community continues to grow. You know, we have a number of TensorFlow user groups. You can see there's about 87 user groups in 37 countries. So that's where I kind of wanted to wrap this, to just, you know, land the idea that there are many ways of learning machine learning. There's many things out there for doing machine learning. There's PyTorch, there's Paddle, there's Grow Your Own Machine Learning, there's Core ML from Apple. But what we've trying to do to differentiate ourselves and to really help the world, according to the economic data that I showed earlier on, is to have that holistic view of everything that you would need to be able to do to be successful in machine learning, to create, you know, to do the big thinking around how that's going to work, you know, from talking with developers, from what we've built ourselves, and to be able to make sure that there's a full ecosystem out there that allows you to do this end to end, that has, you know, free and open source code for all of these things, has accelerated infrastructure on which you can build it, and of course allows you to build responsible, unbiased systems as you're doing. So that's really the end of everything that I wanted to present. This is what we're thinking, this is how we're thinking, and as well as some of the new stuff that we've shipped this year. So I think at that point I can go to questions. Okay, I'll just read the questions myself. I can see, I'm going to start at the...
Hi, Laurence.
Hi. Or do you have...
Yeah, so you have finished your presentation?
Yes.
Yes. All right, thank you. So yeah, we have many questions from students here. Yeah, but before that, we will have 2 students that will ask question directly to you.
Okay.
Yeah. So please welcome Jansen, Jonathan, and Felix Evander to the stage.
Hey, Ryanson. Hey, Felix.
Hi, Laurence.
Cool video, Ryanson. I feel like I'm seeing a star now.
Thank you. Okay, so may I ask the question now, Katia?
Sure.
Okay.
Yes, please.
Okay, so first of all, I'm a huge fan of your work. When I first started this Bangkit thing, and then I watched your courses on Coursera, and I really like the way you explain things, and I can understand the hard concepts now. And yeah, thank you for that. And my question, I believe, is regarding the responsible AI part of the Google ML ecosystem, since I believe this is a relatively new thing, and this is also mentioned in Google I/O and the event that just happened. And what I really want to ask is that as of now, I believe, and this is one of the things that you have explained also, that one of the things that the responsible AI wants to achieve is the part that data is protected, and there is a model car for that, the new development. But my question is there any way, or maybe a developed way, so it's not finalized yet, that can measure that the AI system that we're building meets the principles of the responsible AI? And I believe that's my question.
So, yeah, I mean, I think to build something for any model to be able to meet the principles of AI is just much too generic. I don't think there'll be a tool with that in mind, because I just don't think that can be done with any model in mind. But what we are working on are tools, of course, to help you on the input side as you're building your data, on the output side to make sure that your inferences are in line with what you would expect from the responsible point. But also importantly, for you to be able to understand what your model is paying attention to. So for example, if you build an image classifier model, and that image classifier model miscategorizes something, to be able to debug why it miscategorized that, using things called class activation maps or salients, where the idea behind them is that, with tooling, you could say, it said that this picture is a picture of a cat because, and show the parts of the image that it paid attention to as a heat map. Or those kind of things, those kind of tools that will help you, once you know that you have a bias issue, to be able to fix that bias issue. So those types of tools are there, and are always currently being worked on. But yeah, so like a holistic tool for meeting all of the principles is kind of difficult. But the idea is like, we say that there was those 4 pillars. There's the data one. I think it's relatively easy to build tools on the data. There's the training. It's a little bit more difficult to build tools for that, but to make sure that, for example, biases when you do transfer learning don't transfer to your model, to be able to debug your model for responsible practices, those kind of things are relatively easy to do, and we're continuing to do that. When you deploy your model, to make sure that in the deployment environment, it behaves the way it's supposed to. Is it going to give you a different inference on one camera than it will give you with a different camera? So to being able to spot and deploy and debug that kind of thing. And of course, finally, in the monitoring and maintenance as part of that whole virtuous cycle, to have the tools for checking your data, checking your models, checking your training, and all that kind of thing will be there.
All right, thank you, Laurence. Is that answer your question, Ren?
Yeah, I believe it answers my question.
All right.
Thank you.
Yeah.
Thanks, Ryan.
Okay, so now, Felix, do you have? I believe that you have very important question to Laurence, please.
Yes. So first of all, I would like to thank you for spending the time and be the speaker in this guest speaker session, Mr. Laurence. I also would like to thank you for what you and your team has done for the ML community. It's an honor to be able to speak to you directly, Mr. Laurence.
Thank
Okay,
you.
let's get right into my questions. I actually have 2 questions, so let's start with my first question first. So I know a lot of Bangkit students come from non-IT background, especially in machine learning part. That includes me as well, as my major in university is electrical engineering. Do you think in the near or long future, the skill and knowledge in developing ML models or AI will be essential, or even their awareness of AI? Are those a must-have for everyone coming from non-IT, even though they work in non-IT jobs?
Okay. Great question. And also, I studied electrical engineering too. So my master's was in EE. So, hello, brother. So to answer that question, I think in all fields, at least an awareness of what AI is and what AI is not is essential. I think part of the problem that the industry faces right now is hype, that there's a lot of both positive and negative hype around AI, and that obstructs innovation. So I think in any company where you have business decision makers, technical decision makers, product managers, they all should really know what the boundaries of what's possible with AI and machine learning are. And as a result, like the AI for Anyone course that I mentioned during my talk is really aimed at those. That's the first part. The second part is that when people who are not developers and who do not have an IT background, when they understand what AI is and what AI isn't, whole new innovation can come from them. Let me tell one story as an example. I recently worked on a project for a TV show. And it's a TV show that was on the air for about 10 years. And they had hundreds of episodes of this TV show. And they wanted to see if an AI could generate a script for the TV show. And if it could, they were going to bring in all the original actors and they were going to do a table read of this. So I created this script for them using models that I trained. They brought in all the actors to read it. And if you've ever seen text generated by an AI, it generally becomes silly after a while. It doesn't make any kind of sense. It has made up words, all of this kind of thing. And we did this table read and we laughed a lot and we had a lot of fun with it. But my point of doing this exercise was, here's somebody not technical. They're very smart. They're very good at what they do, but they're not IT background and they're not technical. What would happen to them if I get them through the hype cycle and they begin to see what AI is and what AI isn't? And one of the actors, when we were going through these scripts and I was explaining all of this concept, he suddenly said, wait a minute, as an actor, it's very difficult for me to get new jobs because a new job I have to audition for. And to audition for a new job, and he's a science fiction actor, so to get a new job in science fiction TV shows, he generally has to go and read a script that he's never seen before that has a lot of complicated terms in it. And he was like, well, if your AI can generate scripts with complicated terms in it, that's the whole business for people like me, because I could just use that to generate a script and I can practice. And I know thousands of actors who would pay for that, because they can't afford to hire a writer to be able to do auditions. But if for $10, they could generate a bunch of scripts for them. And he is a non-technical person. Once he understood AI and a little bit and how it works, he started coming up with ideas for a groundbreaking new project and new product that nobody has ever done before. And so those of us with an IT background, with electrical engineering or with programming or all those kind of things, we have a very narrow view of the world. And there's so many people out there with a much broader view of the world who have problems that this can solve that we don't know about. So as a result, I say absolutely yes. And that's really what we want to do to be able to broaden AI.
Okay, that's an interesting story. It reminded me of one of your videos in Coursera where you generate like poetry in using ML models. Yeah, I actually laugh. I laugh really hard when I see you like reading the poetry generated by the model.
Yeah, I had to film that many times because I kept laughing too. It took a lot of attempts to get it right.
Okay, for my second question, like it's a bit deep, technical. As we know, the transistor in CPU and GPU technology is shrinking, just like what Moore's law show. As of right now, we're already at the 3 nanometer technology and are already approaching the limit. Do you think that will hinder the growth of AI development? If so, what will the solution look like? Is quantum computer one of the solution?
I think there's a number of things that can solve it. While my master's was in electrical engineering, I haven't done a whole lot since then, and that was over 20 years ago. So I'm not really an expert in that field. But one of the things that we're seeing for making machine learning more efficient isn't just smaller computers because of Moore's law, but more efficient algorithms. And when we look at, for example, training large models, there's a lot of wasted time in training them, particularly when you are sharding across multiple processors, because you have a section of pre-processing data that takes this long, and then you have a section of training that takes this long. But while you're pre-processing the data, your TPUs or your GPUs are sitting idle, and then you're training them for a little while, and then you're pre-processing the next part. And there's a lot of work going on and research going on in that kind of parallelization that will make training far more efficient on existing hardware. So I think, the Moore's law and the hitting the Moore's law and that kind of thing as things shrink is not necessarily a barrier to faster machine learning. But there's also innovative new technologies like TPUs and, of course, quantum computing. I think quantum computing is still some way off from being able to do this. But, of course, we're heading in the right direction with that. And at some point in the future, that will allow us to do like much more efficient machine learning. But, we shouldn't let the size of the circuit and hitting the 3 nanometer be the only thing that we think of in constricting the ability to do this better and faster, because there's so many ways that it can be optimized.
Okay, thank you for the answer.
Thank you, Felix.
All right. Do you have any other question, Felix and Rian? No?
For me, it's enough.
Yeah, it's also for me.
Oh, you're bored of me already. Is that what I'm hearing?
All right.
Before we take questions from YouTube, can I just take a 30-second break, because I forgot to bring a glass of water and I've been talking a lot. So I'll be right back. Sorry.
Sure. Yeah, please.
Okay, sorry about that. I have my water now. I'm good.
Great. All right. Yeah. So I think it's time for us to answer the question from YouTube comments.
Okay.
Yeah, there are so many questions. Thank you all guys for your enthusiasm. But yeah, however, due to the time limitation, I think we will only choose around 5 best question.
Sure.
And that 5 best question will also win a door prize from Bangkit team.
Nice.
And yeah, the name of the winners will be announced at the end of the session. All right, so let's just read the question. First question, I believe it will be shown up in the box below. From first question from M. Aji Prasetyo. With recent advance in digital transformation, data privacy is becoming more important. How would data privacy awareness affect the development of machine learning in the future?
Oh, I love that question. Yeah, that one definitely deserves a prize. So obviously, machine learning relies on data, and often data is very private, particularly on mobile devices. And they're very, very personal devices, and to get improvement in them requires data to be able to do training, but you don't want to send that data to us or to somebody else to be able to train that with. So one of the things that we've been working on with data privacy awareness is something called federated learning, where the idea behind federated learning is that much of the learning is actually done directly on the device. So the learning about your personal data is done on the device itself. And then the results of that are needed to be able to improve the entire ecosystem, instead of sending the personal data, it's just the weights and the gradients associated with that data that cannot be reverse engineered back to the data itself, can then be sent to a centralized server. And then that centralized server can learn and aggregate from them in order to update models on personal devices. So that's really one of the goals of, particularly I spoke earlier about mobile being one of the biggest deployments. And as you are wanting to create apps that run on mobile that can be personalized, that can learn from the user's personal data, that's a very, very important part of it. So federated learning, there's an API called TF Federated, is designed with that in mind. And so yeah, data privacy is super, super important. And there are techniques where the important things that you need to learn to make a model can be privatized in building centralized models. And there's a lot of research and a lot of work still going on in that space.
All right, great. Yeah, hopefully that answer your question, Aji. And yeah, we will continue to the next question from Kianova Mahendra. It's kind of a long question. So yeah. So the full question is like, as a student learning software engineering, I heard from many people saying that we still live in the bubble where we are still in a trend of a startup, and the startup itself not getting any revenue. Um, uh, it impacts software engineering in the industry itself. But the question is, does this impact data scientists and or ML engineers? Any thoughts on how to survive as data scientist or ML engineer in a fast-paced growing industry? What do you think, Laurence?
Oh my, that is a tough one. Nobody can predict the future, and if they claim that they can, they're lying. But I think, you know, the important thing that we can, to follow the example of machine learning, is that you can learn from the past to at least make an estimation of where things are going. And I think in a fast-paced industry like this one, the important thing to do is always keep your skills up to date. As new roles emerge and as old roles go away or become devalued, it's always good to keep your eye on the future of what those new roles are going to be. And my prediction, I'm not going to say I can read the future, but my prediction, just looking at the data that I shared earlier on about economic growth, showed that the deep technical skills in data, in AI, in cloud computing, in scalability, you know, are the things that are projected to grow the fastest. So if what you're currently working on isn't generating revenue or isn't able to, you know, support you or to support your business, it's realizing the research that's been done in those areas are the things that can help you be more secure. If I give a story from my own history, is that when I first started working as a developer, as I shared earlier on, my master's was in electrical engineering. When I graduated with a master's in electrical engineering, nobody was hiring electrical engineers, you know, so I converted myself to be a programmer. I learned a language called Visual Basic, if anybody remembers that, because at that time that was booming because of Microsoft Windows. And, you know, I learned how to be a Visual Basic programmer. I built a very successful career as a Visual Basic programmer. And then about 6 or 7 years later, a thing called Java appeared. And, you know, the career of a Visual Basic programmer vanished almost overnight. And Java became the world's most popular programming language. But fortunately, I saw this coming. And I saw the advent of the web coming instead of building on a client computer that you would do with Visual Basic. Reskilled myself to that and was able to continue my career. So I think, you know, when you have those technical skills as a data scientist or as an AI/ML developer, it's always very, very important to see what is coming, to keep your finger on the pulse of what's coming. Go to Google I/O, go to Facebook's conference, go to Apple's conference, go to Microsoft's conference, or at least read the, you know, the outcomes of those to see which way the winds are blowing and make sure you get skilled up in them. And also, if you remember when I showed that diagram at the beginning of the economy, and we saw that economic growth as a result of the web, and then it died, you know, or it dropped, and then the economic growth as a result of the smartphone followed, but it followed very quickly afterwards. The downtime was very, very short. And, you know, so that's the encouraging thing, that when you're in tech, is that, you know, when we, like with anything, there are boom times and there are bust times, but the bust times can be very, very short. And it's good for you to see which way the winds are blowing so that you can ride the wave as it goes into other ones. So careers like programmer may change drastically, data scientist may change drastically, but the underlying skills that you have and the underlying technical abilities that you have, if you continue to reskill yourself, is relatively easy to do, and then you can build a new career. I've had to reinvent myself so many times.
Yeah, great. So I think it's important for us to always learn, yeah, Laurence, and to improve our skills, and yeah, to always follow up on the new technology. Yeah. Okay. Thank you for your answer. And then we will move to another question. Yeah, you
I
said
lost you for a moment.
All right. Oh, you lost
Yeah,
me.
back now. I can
All
hear
right.
you now.
Sorry. Sorry, I think it's the internet connection. All right. Yeah, you said you cannot predict the future, but maybe machine learning can do that because it's related to the next question from Dimas Raffi Ramaharmuzi. In the future, can we predict revenue, expense, and investment with the model of machine learning to overcome a crisis?
If there's enough data about past behavior in that, you can create machine learning models to predict future behavior based on the past behavior. That's part of the point of machine learning and AI is, computers are much, much better at spotting patterns that lead to outcomes than humans are. Often humans will define a rule that says, well, if the price of oil hits this much, then the economy is going to go this way. And we have those rules that we follow that we can understand. But machine learning with computers, they can brute force their way through patterns to spot patterns that we don't see and then make much better predictions than we can from that. So absolutely yes, but it takes a lot of effort to get the right data with the right labels, to be able to do that.
Yeah, that's true. That is always be a challenge for machine learning developer. Yeah. So we need to able to collect the right data and of course to cleanse and to choose the right data for our model.
Can I share one example before we go to the next question? Can I share one example of what I mean? And it's related to this question, but it's a little different. And one of the data sets that you'll see in the TensorFlow data sets is the diabetic retinopathy data set. And the diabetic retinopathy research that we did at Google was to keep it a little bit short, but the diabetic retinopathy is the world's leading cause of blindness. And it's very easy to prevent if it's diagnosed early. And it's diagnosed early by an ophthalmologist looking at a scan of a retina, finding blood clots in that one and saying, you're suffering from this today. You need to, go on this course of treatment. So we built an AI model that did the same thing, right? We got lots of pictures of retinas. We built a model using the retinas that were labeled by doctors to say, this is disease, this is not. And we were able to build an AI model that could do the same thing that the doctors were doing, because it was spotting the same patterns that the doctors were spotting. Cool. But here's where it gets really interesting. And this is like where that's one thing and it's amazing, but let me tell you where it gets even more amazing. And that is the data that we had about these retinas didn't just have a label about whether the person was diseased or not. It also had their age, and it also had their gender. And so given that you have the retina and you have the gender, for example, could you train a model that could predict gender from a retina and a retina scan? Now, to be able to spot the disease, you look at the retina and you see the blood clots, but to be able to tell a person's gender, well, what do you do? Right? There's no way of doing it. Or to be able to tell their age, what do you do? So the model that they trained on that, being able to spot patterns that humans can't see, it got the gender correct 97% of the time, right?
Wow.
It should be a coin flip. It should be 50-50, right? Just looking at a retina, because you don't know how to determine gender from retina. It got it right. So it was able to spot patterns that a human could not see. But with the age, it actually got the age of the person to within 3 years, right? You can probably look at me and everybody could guess my age. And I bet if we took the average of everybody's guess, you wouldn't be within 3 years. But with a retina scan, this model could get my age to within 3 years. So being able to spot patterns that human can't spot give you these kind of open up all these new scenarios. So to answer that question about revenue, expense, and investment, having that data from the past, and well-labeled data, computers and machine learning models could potentially spot patterns there that a human doesn't see, in the same way as it could predict the age or the gender from a retina scan.
Wow, that's super cool.
Isn't that cool?
Yeah. Wow. I'm very new about that. Okay, so yeah, I hope that can answer your question. And now we will have another question from Zahrizal Ali. Uh, your TensorFlow course is the best. It was great, and yeah, that's also I agree with that. And but anyway, in the future, do you believe machine learning will be more enhanced than now? Because I believe now machine learning is already so powerful. How can it be more powerful than today?
I
Right.
think we're only getting started. I think there's so much room to grow. And I think there's two ways that we can make it more powerful. The first and obvious one is to make it easier, so that you don't need to be a machine learning engineer to be able to build models. You can start using tools for things like a neural architecture search to help you find the best possible architecture for your model, to be able to optimize that, to be able to choose the right hyperparameters, so that like the many hours that you're spending now in tweaking and fiddling with models could be reduced to minutes, leaving your time to be able to do more important things and to be able to continue to innovate. That's one way that I think it can become more powerful, is by becoming easier. The other way that it can become more powerful is the discovery of new algorithms, new optimizers, new loss functions, new techniques, and to open source and to simplify those, so that, I always like to give the example of the famous cats versus dogs. That cats versus dogs data set is from Microsoft. It can be used to train a model. 5 years ago, that was state of the art. Very few people in the world could do it. Now anybody can open up a collab and do it, right? And so what is it that only Google or only Microsoft or only Amazon or deep learning or OpenAI, what are the things that only they can do today that everybody's going to be able to do in 5 years? It's like that. This is the way I can see things becoming more and more powerful as we go forward. Some of the great stuff in large language models, some of the great stuff in image generation from text, all of that is going to be as easy as MNIST is today. And I think that's, one way, that's the other way that we're going to get much more powerful.
All right. Yeah, thank you, Laurence. Okay. So yeah. There's always space to grow, yeah, to be more powerful from, yeah. Okay. So we will continue to the next question. Now from Alif Rizal. Yeah, what is your view on machine learning in the future? Is there a possibility that machine learning can collect the data it needs by itself? Because data has always been the biggest challenge.
So I'm going to say yes and no. No, because the machine learning doesn't need to collect the data by itself. You can have ways of creating synthetic data. And there's already some pretty sophisticated stuff out there for you to collect synthetic made-up data about something. Let me give some examples of that. First of all, for one of the things that's very commonly used for training things like self-driving cars or self-driving drones isn't to get a car and drive it around on a real street or get a drone and fly it around in the real world. But because of gaming giving us these hyper-realistic, high frame rate, photoreal environments, we can start creating simulations and getting training data from those simulations a whole lot cheaper than doing it for real. And so I think, there's that type of synthetic data is definitely out there. And there's already techniques for you to do that for computer vision and for like object detection and video. That's already very advanced, and there's a lot of great stuff out there. For other data, like statistical data, there are actually tools available so that if you have a data set, and it's a relatively small data set, that what it can do is it'll do a statistical analysis of that data set and generate new records for that data set that fall within the analysis that you have. Say, take, for example, you got a lot of records of, I don't know, people who registered for an event, and you have their names and their age and their interests. And then you look at that and you go, okay, well, we have 70% of it are men aged between 20 and 50. And we can now go, well, if we generate a lot of new records of men with random numbers or random variables according to the distribution in other fields that are between 20 and 50, then they're going to be in line with our existing data. Or if it's, 30% of the women who register are under 20, then it's a case of, well, you have this kind of statistical understanding of your data, so that if you generate new synthetic data that falls within the statistical parameters, you can end up having a much bigger data set where you base it on real data, but you can have synthetic data that kind of matches that, so you can start building with that. So I think synthetic data is a massive, massive growth area for AI. So it's not the machine learning will be collecting the data by itself, but the ability to create tools that will allow people to generate realistic data to be able to do machine learning is a big business opportunity.
All right. Yeah. That's cool. So yeah, I hope that can answer your question, Alif. It's already 5 questions, but we will add more questions because the enthusiasm of the students. Now the 6th question from Pandya Atala Herlambang. It's kind of technical question. With DALL-E 2 and Google's new image generator, both achieving very good FID scores on Coco. I would like to hear your thought on zero-shot learning and how it can accelerate ML vision tasks.
Yeah, I mean, just from a very simple high-level perspective, the less amount of shots you have to do, the quicker your model trains. The quicker your model trains, the quicker you can debug it and you can refine it and you can update it. So I think, that's the underlying core of how you can accelerate ML vision tasks, because there's something like ImGen and something like, I don't know about DALL-E in particular, but you can imagine for ImGen, it's not the first model they created was the one they published. There was many, many iterations and research and evaluation behind that before you can publish the results. So the faster you can iterate on that, the faster you can able to produce something. So zero-shot learning like that is one way of iterating more quickly. It's not the only one, but the more we do on that, of course, then the quicker you can innovate, the quicker you can release new things.
Oh, great. Okay. Yeah, so I hope they can answer your question, Pandya. All right. Is there any other question from? Yeah, we also have one more question from Pratama Azmi. I would like to ask about TFX. How to use TFX for unstructured data, especially signal data. It can different with structured data. All right, any ideas for that?
Oh, that's a really good question. I think for the unstructured data, before using TFX, I would start looking at the tools within TFDS for adding structure to your unstructured data, to do feature engineering on that data and that kind of stuff. I'll be honest, I'm not an expert in TFX. The best person to ask would be, if you know Robert Crow. I'll type his name in the search window. You can find him on Twitter. I'll type his name in the YouTube window, sorry. You can find him on Twitter, or you can send details to him around that. He's our expert on TFX. But typically, I think when dealing with unstructured data, my approach is to use various tools to at least bring some level of structure to that, even if it's padding or filling stuff out with zeros, so that I can do a level of feature engineering to create a sanitized data set that I would then train on. But yeah, I don't know about with TFX, sorry.
All right, yeah. Thank you, Laurence. It's okay, we will do a Google search later. Yeah, so yeah, honestly, there are many more questions, but yeah, due to the time limitation, I think we will stop the question and answer. And I think it's time to announce the 7 best questions Congratulations to the 7 best question. M. Aji Prasetyo, Kianova Mahendra, Dimas Raffi, Rama Harmuzi, Zahrizal Ali, Alif Rizal, Pandya Atala Herlambang, Pratama Azmi. Each of you will get 100 points. Yay! So yeah, in Bangkit we have like gamification. So students will collect points to be in the end of the program they can exchange the point with some kind of merchandise. So yeah, congratulations to you all guys. And yeah, I think we will come to the end of this session. Do you have any closing statement, Laurence?
Yeah, just one that, I just want to say congratulations. You've worked so hard to get this far. And I know there's a lot of new concepts. There's a lot of things that may not be familiar to you, particularly those of you who don't come from programming and engineering backgrounds. I'm biased, I know, but I think you've made a very, very wise decision for yourself, for your family, for your future, for your country. And, I just encourage you to keep doing this, stay on this road. There's always going to be setbacks. There's always going to be times of discouragement. Don't let them stop you. I tell people at Google that, I failed twice to get into Google before I was hired by Google. And, like I always get that response, and it's like a lot of people go, my gosh, you're a leader in machine learning. How come they didn't hire you? There are always going to be setbacks like that. You don't let them define you. And you also don't let your successes solely define you. And it's lifelong learning. It's always continuing to try to strive to be the best person that you can be. Not every one of us can be the smartest. Not every one of us can be the tallest or the fittest or the strongest, but it's always a choice of how you spend your time and how you choose to, what it is that you want to spend your time on. And I think spending your time to be able to learn and expand in something new and exciting like this is a tough decision, but you made that decision and you're succeeding with that. So, congratulations on that. And, thanks for being a part of this industry.
Okay. The closing statement. Thank you, Laurence. Thank you for your time to share. That's very inspiring. It is great to watch all the new technology, new tools, and innovation developed by Google. Hopefully, one of Bangkit students in the future will be able to take part in the development of the new technology in Google.
I hope so.
Yeah, I hope. And I believe that the students are very happy to be able to hearing your speak and to communicate directly with you. Yeah, because previously we can only see you through the Coursera course. Yeah.
No,
so
thank you.
yeah, thank you so much, Lauren, for your time. I think this is the end of the session. Thank you all guys for watching, and hopefully it will enrich your knowledge, and we wish you all the best in your next Bangkit journey. Okay, thank you so much,
Thank
everyone.
you. Enjoy your day. Good night from Seattle.
Okay, good. It's in the afternoon here. Bye, Laurence. See you.
Bye. Take care.